All right, here's a quick lesson here. The next topic in this unit on proportional relationships is on proportional and non-proportional relationships. Okay, what does this word proportional mean? So two quantities, two things that are related there are proportional if their ratio or rate is always the same, a constant ratio or constant rate. If they are not in a constant rate, then it is not proportional, okay? Whatever that rate is, the ratio or rate, depending on whether the units are the same or not, that ratio is called the constant of proportionality, okay? The constant of proportionality. This is also what we would call a unit rate, which you'll see here in these examples, okay? So, for example, here they say, okay, wristbands cost $6 if you buy 4 of them, $9 if you buy 6, $12 if you buy 8, that $3 if you buy 2. Okay, all of these fractions, all of these divisions come out to the same answer. They all equal 1.5 if you divided them, or $1.50 per wristband. Okay, which would be your constant of proportionality. This example, here you pay $6 for 4, but then you pay $10 for 5. And so this comes out to 1.5 and this comes out to 2. So these are not equal, right? When the rates are not equal or the ratios are not equal, then it is not proportional. So how do you determine if a relationship is proportional or not? You divide, you find the unit rates or ratios, and you see if they're all equal. You can do them all as simplified fractions, or you can divide them with a calculator and get them all as answers as decimals, okay? So in this place here, it's coffee. You're buying coffee for a certain number of dollars, right? So this is $3 divided by 1, $6 divided by 2, 9 divided by 3, 12 divided by 4. These all equal 3, right? All of these ratios come out to 3. So it is proportional, okay? The constant of proportionality, that's what this ratio is. The constant of proportionality is 3, or $3 per pound, the unit rate, okay? And that's the example, okay? So here's a got it problem for you to do. Are the number of legs proportional to the number of spiders? Seems kind of common sense that would be true, but okay, so the work that you have to show for this, show each of the ratios, okay, and it should be, this one's not spiders per leg, right? I wouldn't write 1 divided by 8 here. The rate that I'm looking for is legs per spider, so 8 divided by 1, which is 8, 16 divided by 2, also 8, 24 divided by 3, 8, and 32 divided by 4 is 8. You have to check the entire table. Sometimes at the end here, you might have one that doesn't work out to be equal to the other ones, okay? But all of these come out to 8, which means that this relationship is proportional. And what is the constant of proportionality? 8, or 8 legs per spider. 8 legs per spider. Common sense. Okay. Is this distance proportional to the time traveled? If it is, identify the constant of proportionality. Explain your reasoning. When it says to explain your reasoning, when you show the ratios and show that they are equal or not equal, that's good enough explanation, okay, in general. So 50 divided by 1, I usually write this over here, okay, 50 divided by 1. 70 divided by 2, well, you should recognize right away that these are not equal, right? Not equal. This is 35, and this one is 50. And so 50 does not equal 35. I don't have to do this third one. That's a waste of time. Once I get 2 ratios not equal, I can answer the question that it is not proportional. Okay, I wonder what the answer is going to be for this one. Determine whether the ice cubes is proportional to the number of drinks. The work to show, ice cubes per drink not drinks per ice cube. That's not a ratio that makes sense, right? We want ice cubes per drink. 6 divided by 1 is 6. 14 divided by 2 is 7. These are not equal. That's why under this box, I didn't even write anything. I just put it there so it wouldn't look like it was obvious from the beginning. So these are not equal, right? 6 does not equal 7. Depending on how many drinks you have a different quantity of ice cubes per drink. Therefore, this relationship is not proportional. Example 3. A circle's circumference is proportional to its diameter. Use the figure to determine the constant of proportionality. Then write an equation. All right, so we're going to write an algebraic equation to represent this situation. When you have a proportional relationship, you can use the constant of proportionality to show the relationship between the two quantities. Okay, so first find the constant of proportionality. They only give you 2 numbers here, so it's not, you're not checking that they're all equal. It is equal. What is the rate that we're looking for? It's the meters of circumference divided by meters of diameter. Okay, now since these are both meters, this is going to be a ratio that has no units. And the ratio of circumference to diameter is 3.14. You should recognize this, right? That the ratio of circumference to diameter of a circle is known as pi. Okay, 3.14 approximately. All right, so now to write the equation. Anytime we're going to write an algebraic equation to relate 2 quantities together, we have to define the letters that we are going to use, the variables that we are going to use for those 2 quantities. Okay, so in this situation, the variables are going to be C for circumference and D for diameter. There are no units associated with these. As long as they are both the same, this equation will work. Okay, the equation is that C, the circumference, is going to equal the constant of proportionality times the diameter. Here's your equation. Okay, and then you can use the equation to find any circumference given any diameter. Okay, so they say, okay, find the circumference, right? The second part of this is, I would label these different questions, A, B, and C, right? So A would be find the constant of proportionality, that's this part. Then B, write an equation, okay, that's this part, including defining variables. And then part C here would be find the circumference of a circle with a 6-inch diameter. So, in the equation, 6 is D, so I put 6 in for D. I show the substitution required, right? You must show the substitution. Just like we've done this before, okay? And the circumference is, multiply these out, 8.84 inches, because the diameter was inches, so the circumference is inches. The units are going to be the same. Got it? Cost for 2.5 pounds of meat is $7.20. A, find the constant of proportionality. B, write an equation. C, how much will 4 pounds cost? The constant of proportionality we are looking for here is dollars per pound. So 720 divided by 2.5, I'll use 2.5 because I'm going to use a calculator. That comes out to $2.88 per pound. That is the constant of proportionality. So now write an equation that will relate the cost to any number of pounds of meat. So that means I'm going to use 2 variables. Define the variable. C is the cost in dollars. There are units associated with that. And I'll use P for pounds of meat. Okay. The equation then is that the cost, C, equals 288p. You do not have to put units in the equation. Okay. The units come from the definitions of the variables. All right. That's part B. Okay, so we did A, what's the constant of proportionality? B, write the equation, including defining variables. C, how much will 4 pounds cost? Substitute 4 in for P, and you get that 4 pounds will cost $11.52. Okay, that's it. that's the lesson on proportionality. And is it a constant of proportion? What is the constant of proportionality? Is it proportional or not? Define variables and write an equation. Okay, so 3 got it problems. Number 1. Show the work to show if it's proportional. 5 divided by 1 is 5. 6 divided by 2 is 3. I don't need to show any more work. You might want to just write here, 5 does not equal 3, and therefore this one is not proportional. Number 2. Cups of iced tea and cups of sugar. Now these you could do in either way. 1 cup of iced tea for 2 cups of sugar. Probably goes better that cups of sugar over cups of iced tea. 2 over 1, 4 over 2, 6 over 3, 8 over 4. These all equal 2, right? So since they are all the same, it is proportional. And the constant of proportionality is 2 cups of sugar per cup of tea. And finally, number 3, 13 gallons of gas costs $41.47. Find the constant of proportionality. You might recognize here that the constant of proportionality is the same thing as a unit rate, right? Constant of proportionality and unit rate are the same thing. So it's dollars divided by gallons, $3.19 per gallon. To write the equation, the first thing I have to do is define the variables, the 2 changing quantities here, gallons and dollars. So I'll put C as the cost in dollars, and G is the number of gallons. And my equation then is that the cost, C, equals 319G, 3.19G. And then finally, part C here, how much will 18.5 gallons cost? 3.19 times 18.5, $59.02. Okay, so ratios of the 2 quantities are always the same. If they're constant, then it is a proportional relationship. That constant ratio is the constant of proportionality, also known as the unit rate. Then I can use that to write an equation by defining variables for the 2 changing quantities and then writing the equation, which I can then use to find any combination of the 2 values. And that's it.